This program on women in science, technology, and business has been brought to you by Zoho Corporation.
Hello and welcome. I'm Kamla. My guest today is Danielle Applestone. She's an engineer, inventor, entrepreneur, and CEO of Other Mill Company, which is a San Francisco Bay Area-based company. And welcome to the show.
Thank you. Thanks for having me.
Other Machine.
Yeah, Other Machine.
What is this Other Machine?
Well, Other Machine Company is a company that builds a desktop-sized manufacturing tool and the software that runs it. And by desktop manufacturing tool, I mean what used to take up a whole room and mill out parts for you, manufacture parts for you, now can fit on your desktop. And we manufacture that tool in Berkeley.
So when I think of mill and lathes, I think of a big room with machines and that sound that, you know, you want to close your ears, you know, when they mill and lathe, you know, it's that, you know the sound I'm talking about.
Yes, absolutely.
That's all been reduced to like a printing size, like your printer size desktop?
Yeah, it's 17 pounds and about a 14-inch cube.
So it's very, and what can you do with that?
You can mill out prototypes, mostly. For people who are designing circuit boards like these, you can have the design file that you create in your design software. You can import into our software, and then the machine will cut it out with a sharp cutting tool. So you put in a blank one of these, and then you mill out the thing, and you're left with your circuit design. And you can do the same thing with 3D parts, like these are heat sinks, so aluminum parts.
What's a heat sink?
A heat sink is a component that transfers heat from a very hot chip. Like, you know, when your phone gets hot, there's heat sinks that transmit that heat up. So there's a lot of surface area on top here, and all the places where the air can run in will dissipate that heat. So you put a heat sink on top of the chip, and it makes the chip cooler.
Gotcha.
Which these are very hard to prototype. If you wanted to make a few small heat sinks and just try out a different geometry, would be difficult. But with our machine, you can just design them in a CAD program, a design program, and then mill them.
And then these are the other things you can make.
Yeah, woods, plastic, rigid plastic, like Delrin. There, you can also prototype in acrylic and polycarbonate, so like bulletproof glass. Like, you can mill any block that you put in there, as long as it's aluminum or softer, you can mill.
What is that butterfly there?
This is something we like to show because
and that was made in this machine?
Yes. So these are aluminum parts that were milled in 2 dimensions, but it was to demonstrate to students that you could mill 2-dimensional things and form them into a 3-dimensional object. And in fact, a lot of things that are manufactured are assembled in that way.
Gotcha. So they're done in a 2D, but then when they're put together, they give the 3D effect. And what about that?
This was a thing that we designed for engineering schools. So a lot of mechanical engineers do simulations on the computer. So they'll design something, do a simulation, calculate how much load that it should hold, and that's where their education will end. Well, with the Other Mill, you're able to mill out the pieces of the thing that you designed and actually test it. And so this is a truss example. So you can design a truss with all the angles and calculate how much weight it's supposed to hold, and then hang the weight down and actually see, did my truss hold as much weight as I thought it would? And if it didn't, go back to your design and design as something else. And so you're reducing this iteration cycle, and it helps people learn faster.
And is that bracelet also from your machine?
Yes. This is one of my prize things. It says "Make It So #1" in a Star Trek font. Was one of the first.
So you're a Trekkie?
No, but I really love the font.
Ah, okay.
I mean, there are people who I love Star Trek, but not a Trekkie compared to other Trekkies.
So what material is that?
This is brass. In this case, this was a piece of brass that I got from the hardware store, which was just a strip, and then you mill the saying into it and then curve it around, you know, depending on how big you want it to be.
So how much did it cost you?
This was 65 cents.
That's it? Mm-hmm. I want one of those machines so that I can make those and sell.
Yeah, well, that's where we think, you know, we're starting with electrical engineers who want to prototype more quickly, mechanical engineers, but there's no reason that jewelers wouldn't use this, for
So
example.
you have a piece of jewelry there.
Yeah, silver jewelry, and also the one that I wear. Very intricate.
Those are, what do you call them?
Wrenches.
Yeah,
wrenches. People who are doing jewelry design and learning art in schools are becoming more and more exposed to CAD, computer-aided design software. And so now those people know everything they need to know in order to use our machine. And so they will also start over time milling out their own products.
So you are starting a revolution of kind by this desktop manufacturing, because your target audience, it turns out, are educational institutions.
Yes.
And students.
Yes.
So I think it is reinvent the shop class for 21st century classrooms. I think that's one way of describing what you're doing.
Yeah, our origins were to do just that. We were a DARPA Defense Advanced Research Project Agency. We were a DARPA-funded research project, and the reason why we were paid by DARPA to develop these products was they wanted to put shop class back into high schools, but instead of just being hand tools and manual labor type of skills, they wanted to bring digital design, computer-controlled manufacturing into schools to get people exposed to that kind of technology as early as possible.
So that's how it started. How did your interest in math and science start? You grew up in Arkansas?
Yes. Yeah, I'm from Mena, Arkansas. It's a town.
Mena is M-E-N-A?
Yes.
Okay.
Town of about 6,000. And my interest in math and science was really about survival. I think that...
What do you mean survival?
Whenever you see a problem around you and you want to fix it, you need to be able to understand it and then use everything in your power to solve that problem. And for me, my dad was in a wheelchair, and so we were...
He was in a wheelchair because?
He's a disabled Navy veteran.
Oh.
And so we had to modify things around the house in order to be accessible for him. And I think that's kind of how it started with me as an engineer.
Are you the only kid?
Yes. Yeah.
Oh.
Working with my dad. So working with my dad to design things, and him giving me the kind of respect that I think that allows an engineer to grow. Like, what do you think about this? Why don't you measure this? Why don't you go pick
Is that
out
what
a
he
part?
said?
Yeah, things like that.
So he didn't treat you as a girl in the sense that, oh, you're a girl, you can't do this.
Right. No, I had no idea that I was a girl until I left Arkansas. Kind of.
Really?
in the sense of
Not being challenged.
Exactly. I
That your gender
of course,
didn't play a role into what you could or couldn't do.
That's exactly right.
Okay.
Yeah.
So your father gave you that leg up, or whatever word you want to use. He didn't. He just expected you to execute
Yes.
whatever he told you to, and he didn't think that because you were a girl, you couldn't use the measuring tape or go to the hardware store.
Yeah.
So did you go to the hardware store often?
Yeah, the hardware store is one of the best places to hang out in Mena. There's not a lot there. But in a hardware store, you see all the future of what you will build, because you go into the hardware store and you can investigate things and you're like, oh, I didn't know that kind of jack existed, or I didn't know that pipe fitting existed. And it becomes the way that you build your mental model about what's possible to build.
So you developed a mental catalog, as you like to
That's
say.
right. Yeah.
Could your dad come into the store?
Sometimes I do tell this the story about him hanging out in the car and sending me into the hardware store because the aisles were really narrow and it was just easier to give me a list, and I would go in there and try to figure out what kind of size pipes or what type of thing to buy, and talk with the hardware guys, and then come out and bring stuff and show him, and he was like, okay, that one, not that one, So we
and the store guys didn't say anything to you.
No, I mean they knew it. It's such a small town. Like
Okay.
everybody knows everybody.
So you learned to use a screwdriver, a wrench, a drill bit, everything by the time you were a teenager, I'm guessing.
Oh yeah. I mean, by the time I was 8, I could pretty much use saws and everything. Yeah. I think my parents both played a big role. My mom was really into math when she was in school, and they never really consider that there should be any kind of limits on what I would do. So, yeah.
So you said it was survival. So what is it? So is that how you developed your curiosity for math and science?
It
how
is.
things work?
Well, if you are living in a rural place and it's the mid-'80s and you're trying to make something wheelchair accessible, there's not a lot of things that exist for you. Like, you can't even order things from Amazon. You can't look online for any solution. You have to go to the library. You have to draw from everything that you see. It's just not very much, but you need these things to make your life better. And I do think that it's survival. And in some cases, it's like, you know, something gets stuck somewhere and we can't go to town until we get it unstuck because, you know, there's just, you run into these like mishaps and your ability to solve them is your ability to, you know, drive to town or survive in a smaller way. You know.
So it looks like your family was very solutions oriented.
Yes.
There was always an answer somewhere out there.
Yeah, always an answer, and the faith that between the three of us, we could solve it.
Okay. So how did you then end up at MIT? Were you a good student?
Well, it depends on what school I was at.
How many schools did you go to?
Well, in my hometown, it was just I think a limited perspective on what a middle school or a high school student should be capable of. And I found out about a math and science school that was in a few towns over in a much larger city, and it was a statewide magnet school. And I applied there and got in. And
all on your own?
I did, yeah. Well, I had a couple of teachers that helped me, and you know, my parents helping me interview for, you know, practice interviewing for a school, which I had never done before. But that school, I was, I think, maybe middle of the pack. And then from that math and science school, I learned about MIT, and I learned about all the quirky projects that went on at MIT, and that really appealed to me. I felt like I see those people. That's me. I want that for myself. And I applied there, and I was the worst student from the perspective of being thrown into MIT, which is so crazy from where I started out. It took a lot of catching up, and I think after I got into the rhythm of it, it was the perfect place for me. But in the beginning, you know,
Were you miserable in the start?
Yeah, I failed very many tests in the beginning because I didn't understand the caliber of work that they wanted to be done. I didn't understand the volume of studying I would have to do, and it was just very challenging. So I've had the experience of being kind of the top dog and also the one who has to struggle for a while.
So there was this, you know, a cultural misfit because you went from Arkansas to Boston, where, you know, like you said, students came from all over and the bar was very high. What was it? Why did you not do well in school? I'm just curious. And how did you then get yourself out of that sinkhole?
I wasn't aware of the pace. It was very fast-paced at MIT, and so you were expected to...
Do they have a quota system?
I don't know. I think it might just be semesters.
Okay.
But you were expected to digest a huge amount of information, and my rate of information absorption was slower than that. And so it took me time to get used to taking in all of that information, like at the rate that they wanted me to. And I think by the end of it, I was a great student, but it took some getting used to because you've never had information delivered to you at that pace before.
Did you ever think of leaving the school?
I think everybody thinks about leaving MIT.
I'm wondering why you persisted. I'm wondering if your childhood, you know, the way you were brought up and how you learned to fix things for your dad, whether that gave you a certain amount of resilience, a high degree of resilience that had you stick on even though you were going through this bumpy ride of your first year at MIT.
I think that
as a woman, you have other challenges because you went there to study chemical engineering.
That's right.
Yeah, so you're in the engineering department, so it's not easy to be in engineering department. And then the second thing is that you're struggling there. So I'm wondering whether your childhood experience helped you, gave you that reservoir of confidence, resilience that said, you know, I can do it. Did you talk to your parents about it?
I did talk to my parents a lot when I was there the first year. The thing that made me feel like I would succeed at MIT was the ability to solve any problem. Like, I've seen this before. Like, I have been in a situation where I didn't know anything, and I have come to a great solution by drawing from the things that I see. And that's what you do at the end of the day at MIT. It's about learning to learn, learning to problem solve. And whether it's chemical engineering or environmental engineering or biology or music even, it is about seeing a problem, breaking it down efficiently, and learning the pieces that you need, and then bringing it back together again.
Which is what you learned as a kid.
Absolutely.
Okay. What did you learn from MIT?
I learned how to take in information at this incredibly high rate. I learned that you don't have to be the best to be good. And I also learned that I can solve problems. I learned to solve problems in a way that I think draws from a lot of disciplines. So they'll just let you take as many classes as you want, or at least they would when I was there. And so you could throw yourself off the deep end, draw from all these different areas, and then use them to solve a problem. And often the most important and most unique solutions to problems come from this overlap of disciplines that wouldn't necessarily come together before: mechanical engineering and music, or biology and ocean engineering or something. The people who have a really broad understanding can draw from all of those and come up with really unique solutions to problems.
So you believe in a really broad base of knowledge?
I do.
Okay. And then it looks like you didn't really like working on chemical engineering?
No, I kind of wanted to get out of Arkansas so bad. I just said that I wanted to do chemical engineering because I was like, well, I like chemicals, I like engineering, I want to engineer chemicals. But that's not really what chemical engineering is.
What is chemical engineering?
Chemical engineering is someone else invents a chemical, and then you just make a lot of it. So it's all of the process associated with manufacturing and refining a chemical. What I really wanted to do was material science, but I'd never heard of material science when I was in high school or anything, so I didn't know that's what I wanted. And it took me 3 years to realize that chemical engineering wasn't what I thought it was.
So if Danielle was in high school today and she had all the things that are at her disposal, Google, everything that's there today, would that young Danielle go back and do chemical engineering, or would she do material science?
I would start a business. I wouldn't do either one.
Really?
Yeah, totally.
Did you know you wanted to be in business when you were a kid?
I definitely have an entrepreneurial spirit, and now that I have seen the power of being independent and having an independent income and being able to organize a group of people towards a goal, entrepreneurism and running a business is just so powerful that I would have done that. And then I could have had more time to figure out what it was that I wanted. Maybe I did want to
study,
do something else.
To study, okay.
Yeah.
So then you went to do a PhD at Austin, and you actually worked, your thesis was on battery technology, and you were interviewing at Tesla.
Yeah, after I completed there, I interviewed at Tesla.
Yeah. Now, you say you hack, your favorite word when we spoke before this thing was you want to hack the system.
Yeah.
And your eventual goal is actually to go back to your passion, which is build battery technology.
Right. Yeah, I have the perspective of an entrepreneurial thinker. And I also have the perspective of a material scientist who really is into the fundamentals of that area. And what I would like to do is bring those together and dictate strategy about where we should be putting our resources for energy, storage, materials, research for the next 20 years.
So this is a detour?
This is teaching me a lot about how to fundraise, how to attract talent, how to have a great team working towards a really difficult technical goal.
So this is your trainer wheels?
This is my training wheels.
Okay.
Yeah.
And you've also done, you say you've mixed flavor of raising money. You've done everything, Kickstarter, angel funding, A-series, and now I think you've taken a loan out?
Yeah, we've done it all, like from venture debt to crowdfunding, angel investment, like all the things that you listed. It's
Why?
been, well, you just need to keep going.
It's
As
like
long as
tasting
you keep
different
going.
flavors of ice cream. It's like, I want to know whether this vanilla is...
No,
Oh.
no, I would have loved to just have one big check. That would have been awesome. But it's a very new idea. So you have to prove things along the way. Like it's not a clear winner for people to see that far in the future. Like to see desktop manufacturing is going to be the future. And they're like, well, you're just building a circuit board. And so you have to get a little further, tell the story, and raise some cash. Get a little further, raise a little bit of cash. And I think for something that's hardware, that's kind of typical. It's a slower fundraising cycle, much different than software. It seems like if we were software, we could just raise 20 million, on a
So
prototype.
hardware is difficult?
Yeah.
Okay.
Yeah, much harder.
If there's a young person out there and she's a woman or a young teenager, what advice would you give her? Because you said that the young Danielle would have become an entrepreneur.
Yeah.
You took the long route. You went to MIT,
Yeah.
UT Austin, and then back to Silicon Valley, which is where, it's the hub of everything. Did you want to come here?
I just wanted to go where the most opportunity was. It didn't really matter where that was.
So what would you tell a young person who is like you say in some place in Arkansas and didn't know that there was a magnet school, but
A female person?
Yeah.
I would say get a job as soon as on the day that you turn 16.
Really?
Yes.
Why?
Work hard, earn money, and get experience dealing with a lot of different types of people.
That is the most important skill?
That's the most important thing. Because you need financial independence from your family or from a partner or whatever. That's the most important thing for a woman, I believe.
So dealing with people. So what are the challenges that you have had to overcome to run your company?
Fundraising was the biggest one. There's not very many hardware companies. There's not very many hardware companies that sell something that's $3,000 that needs manufacturing. And so just getting the vote of confidence with dollars from people was the hardest part. From that, there was the manufacturing challenges, because we make something that is about $3,000, very complex, needs to be very high quality, but we're only building 1,000 to 3,000 of them per year.
Oh.
And so we can't go to China and find a large contract
So
manufacturer
you're
to work
the math
with us.
geek. So 3,000 times 3,000 is how much? That's the amount of money, right, you're making?
That's when I'll feel comfortable.
Oh. You have some magic.
That's right.
How much does it take a lot of money to manufacture in San Francisco? Because it is an expensive area. This Bay Area is very expensive, and this is where you're manufacturing. And you've contracted to a woman-owned company, I believe?
We do have a number of Bay Area partners that are manufacturing components for us. One of those is Bishop Weiscarver, which is owned by Pamela Kahn. Her dad started the business, in fact, about 65 years ago.
Oh.
So we were forced with the decision of we can't go with a contract manufacturer to make our whole product.
Like a Flextronics.
That's right.
Yeah.
That's right. That was not accessible to us, and nor did we need that capacity. But what we had to do was find a space. We found a space in Berkeley, about 5,000 square feet, which was what we needed. And then we have an array of partners. I think it might be 30 to 40 partners that manufacture components for us. And then we bring all those components together, test them, quality control, do the final assembly in Berkeley, and then ship to customers. But that is not typical. That's not the solution that you would read about, for example. It just doesn't happen very often, but I think that's more the future. The smaller batch, higher quality manufacturing that's done locally.
So you think there's a trend there?
Absolutely.
So this is not the maker movement that we read about. I was at the Maker Fair recently. Would you fit into that kind of a scenario, the Maker Fair kind of a scenario? Who is your target audience?
Our target audience is professional engineers.
And students? Well,
professional engineers, whether they're about to graduate or they've already graduated.
What about women and the artists and jewelry makers and all of that? Do you target women?
No, not actively.
You don't?
We don't not target women, I guess.
Got you. Manufacturing is something that you don't hear women in manufacturing.
Right.
Do you have any numbers as to how many women are there in the manufacturing sector heading a company like yours?
Well, I think the number of women CEOs is really small already.
Is it single digit or double digit?
It's single digits.
Oh, okay.
And so manufacturing is a subset of that. And I think even the number of women manufacturers who are in the industry is 2 to 3%.
Okay. Who was your mentor or the person who inspired you when you were doing all of this? And I also want to ask about your husband.
Sure. So for Other Machine Company, I was brought into the government project by a guy named Saul Griffith, and he runs an R&D incubator in San Francisco, which has a lot of energy and robotics related companies that they spin out. We were one of those. He was instrumental in helping me decide between going to Tesla and researching batteries there and developing a new class of batteries for electric vehicles, or coming and trying to solve an education problem, which that one really tugged at me because access to tools was so important to me. I wanted to give access to even higher tech tools for students. And we know now that it's going to be a slow process of adoption from higher ed all the way down into middle school. It'll happen eventually, just like 3D printers, I think, are paving that way. But he just said to me, he's like, would you rather be an engineer solving a problem, or would you rather enable millions of engineers to solve the problems that they see? And it was like, yeah, I think you got me. That's what I need to hear. So I opted to come and run that project.
And what about your husband?
All the things about Joseph, my husband. Yeah, it is an interesting situation he's from Oklahoma, to be a woman from the South with a man from the South and have our traditional gender roles be switched and be the breadwinner. But he is really incredible. He's a musician, and he has taken on the more traditional role of the homemaker. And we have a son who's 11. And
you have an 11-year-old son.
Yeah. I think that if women are going to succeed in technology especially, you really need the support of your husband or your partner, or whoever it is, your other partner, because there's probably not a lot of other women like you at your work, and there's not a lot of models for you to follow, and you really need that support to come home and be like, this day was a nuts day. Like, I need someone for me to be taking care of the things that need to be taken care of around the house, and just supporting you.
That's a rare.
I know, he's incredible.
Yeah. My last question, we only have 30 seconds.
Sure.
If you had 5 minutes with Elon Musk, because we're going to join his company, what would you ask him?
I would ask him what he does in his spare time.
Do you think he has spare time?
Well, that's what I want to know.
He's running so many companies. Do you think he has spare time?
I don't know. I really don't know. I just want to hear him say anything. Yeah. I like seeing how people are when they're real. And I think that it would be awesome to be in a room with him, just me and him, so that I could get more of a sense of what he's into in general, what motivates him.
You're in the Bay Area, it'll happen. Danielle, thank you so much for coming and talking about Other Machine. This truly is another machine, and you want to revolutionize the classroom setting and take it to the 21st century.
Absolutely.
So desktop, so manufacturing has truly come to our desktop. Who knew, huh? Thank you so much.
Thank you.
And thank you for watching. If you missed any of our show, you can catch them on our YouTube channel. We'll be back again with another edition of our show. Until then, goodbye.
This program on women in science, technology, and business has been brought to you by Zoho Corporation.